Hello, and welcome to AV Cyberactive.
In this course, I will introduce the various ways monitoring can be enabled in Linux, on individual hosts, in Windows, and in cloud computing environments. Next, I'll explore how to forward log entries to a central logging host in Linux and in Windows. I'll then discuss how to monitor cloud-based web application performance moving on. I'll examine how to download and configure the snort IDs by creating IDs rules for Telnet and ICMP network traffic. Lastly, I'll discuss how to analyze packet captures for suspicious activity and how to mitigate monitoring deficiencies. Let's take a few minutes to discuss security incident detection and response. More specifically, we want to focus on certain tools that can be implemented to detect security incidents and potentially do something about it when they're discovered. So when we talk about incident detection and response, we really need to focus on filtering out irrelevant data. Some tools, if they're not configured and tweaked accordingly, and that will differ from one environment to another, just generate way too much noise to the point where security technicians get weary of all of these alerts that might mean nothing at all. So it does take some very fine tuning, but in the end it's all about identifying potentially suspicious activity. Now, in order for that to work, we have to have a baseline of what is normal. There are a number of different protocols and standards that apply to this, one of which is the Security Content Automation Protocol, otherwise called SCAP. Now, this specification is a framework that is actually adhered to by a number of tools, security tools that deal with vulnerability assessments, including checking for patches, looking for security controls and compliance with certain regulations, measuring security events. This is all part of SCAP, so it's really designed to facilitate keeping up to date with ever-changing cybersecurity threats. And this is because SCAP tools normally have a database of the latest CVEs. Now automation means that we can compare various types of configurations at the host level, at the network device level, at the network level, even at the app level against pre-configured baselines of what we determine is normal in our environment. Baselines are so important with security incident detection. This can then identify any security policy compliance or of course violations, and it allows us to manage any discovered vulnerabilities. Now there are a couple of components related to SCAP. One is the content module. These modules are available from the National Institute of Standards and Technology, so NIST, and other parties that determine what security configuration should look like. Whether it's for Federal Desktop Core Configuration or FDCC for government agencies, and SCAP content modules work hand in hand with the SCAP scanner engine. This compares our security configurations against these content modules in terms of what security configuration should look like. When you are monitoring for security incidents, it's important to understand the difference between the variations of true and false security indicators. So for example, when we have a false positive such as there is malware on the system, well, it could be just something like temporary app installation files that get flagged as being malware, but really there is no malware. So that's a false positive with a true positive such as a network DDoS attack is in progress. This is in fact correct and is actually happening. Another variation is a false negative such as the downloaded file is free from malware. No worries here. However, the malware might use some kind of technique, some kind of obfuscation or directive name replacement in file headers to prevent malware detection. Then we have a true negative such as network traffic volume looks normal. No problem here. Okay, so activity is determined to be acceptable in this example, and it really is. What we want to do is focus on reducing false positives. That's what wastes time. So we need to configure our rules for security detection to detect the bad stuff, but at the same time get the noise out of the picture, reduce the amount of false positives. And it's all based once again on a baseline of normal acceptable activity and normal and acceptable security configurations. Enter Security Information and Event Management, or SIAM, sometimes pronounced CM. It's up to you how you pronounce it, as long as you know what it is. So with the SIAM solution, we have a centralized tool. This is software that is configured to ingest activity from a multitude of sources, whether it's data loss prevention configurations running on servers to prevent sensitive data from being leaked out of the organization, whether it's from intrusion detection and prevention systems or network device logs, antivirus alerts, server logs, whatever the case might be. So the SIAM solution is designed then to any events that it ingests to determine what's relevant and what's not, and even correlate events that might be related to other events, perhaps even in the past, such as there is now a Linux host on the network, but there wasn't before because we are a Windows shop. So what's up with that? And of course, we can configure real-time security alerts based on potential security incidents. And this is the type of solution that would be used by larger enterprises, which will go hand in hand with security, orchestration, automation, and response or SOAR solutions. In many cases, the SIAM and the SOAR solution is one tool, so it allows for automated incident response based on the ingested data from a SIAM system, and it allows for this automation via what's called a playbook. Think of a playbook kind of as a flowchart or a script that does checks to see what's going on to determine if any action needs to be taken to contain or eradicate an incident. So as an example, consider this sample SOAR playbook where at the beginning an email arrives and it gets checked by our configuration. So a suspect email is received. We parse and evaluate the email, and in the next step, does that message contain a URL or a file attachment? If no, then there might be an email to notify the user that the message has arrived, and that's the end of it. But if there is a URL or an attachment, then for file attachments, maybe computer hash if we have something to compare it to see if the file's been tampered with, or send that hash to VirusTotal online. VirusTotal.com online is a free service that has hashes for known malicious files. It's a quick way to do a quick comparison. If it is a malicious hash, then our playbook might delete the email, notify the user, and that will be that. If it's a URL, then the URL could be sent to VirusTotal.com, and if it's a malicious email, then it gets deleted. Now playbooks can do so much more beyond this type of thing. It's not just limited to email, but this gives us a general sense of how it can prove very valuable. Item A09 for the OWASP Top 10 2021 is all about security logging and monitoring failures. And if we were to dive into the details for that OWASP Top 10 item, one of the things in the description it references is logs that are only stored locally. And so one of the things that we have to consider, even though we're focusing on website application security, we have to think about the fact that we don't want logs for the host operating system or application container or web app components all stored just locally on the host. Because if that host is compromised, so are the logs. What we need is a way to forward log entries from a web app off to other hosts. And not just the web app, the underlying operating system and all of the supporting components that support that web app. And what we're going to focus on here is how to forward log entries from one Linux host to another. The idea is that we would have a protected centralized logging host, perhaps on an internal network that all other servers send their logging information to. So here on my Ubuntu Linux host, I'm going to configure this machine as being the one that receives log entries from other Linux hosts. So in other words, it will be the logging server. So what I need to do then is run sudo for elevated privileges, and I'm going to run the nano text editor against /etc/resyslog.conf. Now, because it's the first time I'm running as you do with elevated privileges, it wants me to verify the password for the user I'm currently logged in as. So I'm going to go ahead and enter that information. And here in the resyslog.conf file, what I need to do is decide whether I want to use UDP or TCP as the transport for receiving log messages from other hosts. Now normally UDP is used, so I'm going to remove the # the hashtag to uncomment the first line for module load imub, and right below that I'll do the same thing. I'll remove the hashtag to uncomment that line where we have input type equals imad and notice that the default port number that this centralized logging host will listen on is UDP port 514. Okay, so now that we've got that done, I'm going to press Ctrl X. When it asks to save the modified buffer, I'll type in the letter Y for yes and I'll press Enter to confirm I want to write to that file. So what I need to do now is I need to restart the syslog daemon, the service. So I can do that with sudo service syslog restart. So I'm going to use the up arrow key to bring up that previous command and change restart to status so we can check on the status of the service, and indeed, it's active and running, and it doesn't appear that there are any errors. So excellent. It read the changes in the file. There are no syntax errors in the file. Everything looks good. We can even verify this by doing something like this. We might run sudo netstat. Now the netstat command can be used to show the listening state of any services that are running on the host, and I'm going to add -n. LP where n is numeric, L means services that are in a listening state, and P meaning I want to see a program because I'm going to pipe that to the Linux line filtering tool grep and I want to look for our syslog, and when I press enter, sure enough our syslog shows up as running UDP port 514. So what this means is we know that it's in a listening state, it's up and running on our server, it's ready to receive log entries from other hosts. So let's run ifconfig to see what this host's IP address is. It happens to be 192.168.4.95. Well, we're about to go to a different Linux host to configure it to forward log entries to this one. So we need to know this one's IP, and now we have it. Let's flip over to another Linux machine. So on a different Linux machine, I'm basically going to edit the same file that we edited on the first Linux host that serves as our logging host. That means I'm going to run sudo nano. So nano editor /etc/syslog.conf. It's going to ask me for the password for the user I'm logged in as. I'll enter that in, and what I want to do is I don't want to turn on the UDP listener because this server will not be the centralized logging host like the other one is. Instead, I'm going to go all the way down to the bottom, and that's because what I want to do is I want to add a new entry to tell this host, forward your log entries to our centralized logging server. Now what I can do is something like this ***. What does that mean? That means I want log entries from all sources. That's the first asterisk ***. The second star means all types of entries. For example, look up above here. If we want to send only mail error messages, then we could specify mail.err or mail informational messages from the mail facility on this host. We could use mail.info and we could see all the way at the top that there are different sources like the cron scheduling daemon or kern for kernel or LPR for printing or user-based items, user. Whatever the case might be, whatever the priority is. So what I'm doing here is saying I want all log entries forwarded. Now you may or may not want that, but in this case I know that I do. Then I'm going to put an @ symbol because I have to tell it where I want to send all of those log entries, in this case 192.168.4.95. That was the IP of the other Linux host. Okay, so let's see what happens here. Ctrl X to save. We're going to type in the letter Y to save the modified buffer. We're going to press Enter to write this to the resyslog.conf file, and we're going to have to restart the resyslog service here on this host, just like we did in the other one. Sudo service resyslog restart, and let's just do the up arrow key thing, and let's change restart status to make sure it started up okay and that there are no errors. So on this Linux host once again it's active and running. This is the resyslog daemon for logging. There are no error messages, so I'll press Q for quit, and so far so good. How are we going to test this out? Well, we can just wait for log entries to be sent over, but we can force it using the Linux logger command. So logger that type of logger, and in quotes I'm going to specify test log message from let's say Kali Linux close quote. So that logged message then should have been sent off to our centralized Linux logging host. Let's check our work here on that host as you do cat, and cat shows me the entire contents of a text file like /virus/log/syslog. Why don't we pipe that to grep and filter for something we know is in our test message like Kali. So if we do that, sure enough we have our test log message from Kali Linux, which is now showing up on our centralized Linux logging host. So this can go a long way. Monitoring the performance of a web application is important because we want to make sure that users have the best possible experience. We want things to be quick, we want them to be reliable, stable, and we want them to be secure. So in the Microsoft Azure Cloud, I've already deployed a web application, otherwise called an app service. What we can do is we can work with something called Application Insights to get detailed monitoring of the web app down to breaking apart different types of HTTP transactions including errors or failures, looking at things like web page response time and so on. So here in the Microsoft Azure portal in the left-hand navigator, I'm going to select App Services. This is going to show me any web applications as well as function apps and logic apps, some of which might be running, some of which might be stopped. Let's start by going into a web application itself. Now when you're in the properties of the web application, down on the left under Settings, you'll have an option called Application Insights. If you click it, you can choose to enable it or disable it. Now you also get this option when you're creating the resource, when you're creating the web application initially, but obviously, you can change your mind at any point thereafter. Up above we have a link to view the Application Insights data. So notice that the type of object we're looking at here is an app service, a web application in the Azure cloud. If I click View Application Insights data, it takes me to an Application Insights type of resource, so it's a separate object or a separate type of resource in the Azure cloud. Now immediately on the overview page, I've got an overview of some things like failed requests. Looks like there are none, at least within the last hour. That's the default time span. I've also got server response time that's being charted here in terms of measuring it in milliseconds. 1 millisecond is 1,000th of a second. It then calculates the average server response time is 12.38 milliseconds. Now depending on the nature of the application and how many users are concurrently using it and what it's actually doing, will determine if that's an acceptable value or not. You can set a baseline over time by monitoring this and saying yes, that is an average server response time when the application is performing well. So setting baselines is going to be important to determine if you have situations where things are unacceptable in terms of performance down below, number of server requests and the overall availability of the web application. Now what's also informative is clicking Application Dashboard up at the top. So that gives me a dedicated dashboard for all of these different types of metrics. So the unique sessions and users, failed requests, server response time, some of these things we saw already on the overview page, then an average page load time breakdown down below, any web browser exceptions for clients, the average CPU utilization for the web app, which is very low here versus the amount of available memory in terms of an average. So again, to attach true meaning to these, you need to set a baseline of what is deemed as being normal when things are performing well for this particular application. Now I can also double-click on a part of a graph to zoom into it. So now that takes me into performance. I could have clicked performance as well and I'm still in the Application Insights resource, not in the web app, although this is related to that web app. So then I'm starting to get some details for the number of requests and the amount of time it took to service those requests in terms of milliseconds, then the duration of requests to the web application. And down below we have some tabular information that represents the same type of thing, in this case for HTTP GET operations. I can also click failures on the left here and view failures in this way, so failed request counts. So depending on the activity for your web app will determine what you see here. But that's only Application Insights for a web application. Let's go ahead and click the X in the upper right to close this, and I'm going to discard any changes that I might have made to this dashboard. I don't want to save anything, and I'm going to go to my virtual machines view on the left and open up an existing virtual machine. Now the reason is because if you've manually deployed a VM, you might have an application running within there. Maybe you're hosting a manual web server instead of having it hosted in Azure. Maybe you just have custom code running in the VM, but you want to be able to track and monitor its performance and availability and the number of failures. So in the left-hand navigator I'm going to scroll down under the monitoring section where on the left I can click inside. If I scroll down a little bit, I can choose to enable Application Insights for the virtual machine. We then get a message stating that Insights deployment is in progress. Okay, before too long the deployment is complete. So if I were to go back into that virtual machine's properties and down on the left under monitoring, choose Insights once it's had time to gather some activity. Metrics from that virtual machine. It will be available here. So we can look at the map, we can look at performance, and we're already starting to get some details for the different disks within that virtual machine. The size, the space used, the IOPS for reading and writing, where IOPS stands for I/O operations per second, which is a measure of disk throughput. And as I scroll down, some CPU utilization information, available memory. And it's always important once again to establish what is normal when things are performing well. Set a baseline so that when you're looking at these things, you can determine if it's abnormal or if it's within acceptable parameters. If I go back to my app services view, besides web apps, we also have function and logic apps, both of which, if we go inside their details, we can scroll down and view application insights. If it's been enabled for that particular, in this case, function app, we can view the application insights data. So it's a standard way to view detailed information for monitoring purposes for applications. And remember, we want to monitor our web apps not just to optimize performance, but sometimes a performance spike can also be indicative of some kind of a security breach. Intrusion detection and prevention is one aspect of maintaining the utmost in security for a web application and its surrounding environment. So in order to detect intrusions, we need some kind of a way to ingest data and analyze it. Now this data of course would include things like logs from web servers, web app logs, performance metrics that might identify suspicious activity, all of that type of stuff. So we could also take a look at things like network traffic beyond the logs that we've discussed. And we need a way to filter out the noise. We need to reduce false positives where a false positive states that there's a problem and in fact there is not. Maybe it's perfectly normal, for example, for the CPU on a web server to spike to 90% for 10 minutes. During a peak time when there are multiple concurrent users using the web app, maybe that's normal, but we need that normal baseline to determine that. Now intrusion detection can also allow us to seek out indicators of compromise. This is where the normal baseline comparison to current performance metrics kicks in. Now there are two primary intrusion detection types. There are those at the host level and then at the network level. At the host-based intrusion detection level, we're talking about detecting things like phishing email messages or malware infections, maybe suspicious files that are on removable media like USB thumb drives. We also want to be able to detect physical access to a device. For example, if someone gets physical access to a laptop computer or a desktop, they might be able to circumvent many security features, such as installing a hardware USB keylogger on a desktop computer. Of course, there would be potential software vulnerabilities if the software is not configured accordingly or patched on that host. So we need a solution that can detect all of these types of things. At the network level, we need to be able to detect unauthorized network access, unauthorized network scanning, such as having port scans occurring when they shouldn't be, or packet capturing occurring when it shouldn't be. We need a way to detect rogue wireless access points, which could allow malicious attackers to gain access to the network without physically being in the location, at least not too far away. So an intrusion detection system or an IDs can be host-based, where it can do file integrity monitoring and app user behavior analytics to identify something that might look suspicious. Network-based intrusion detection systems would include sensors, which come in the form of software or specialized hardware appliances that need to be placed in the right place on the network to see the appropriate traffic flow. So there would be network traffic analysis, maybe even a wireless intrusion detection system or a WIDS solution. So an IDs then based on host and network monitoring can detect security incidents, log, alert, and notify. But an intrusion prevention system or an IPS has the same capabilities as a host-based intrusion detection system and a network-based intrusion detection system. So HIDS and NIDS. But it can also take steps to block attacks, and that's where an IPS differs from an IDs. So it can block based on things like IP addresses, DNS domain names. It can enable black hole routing for excessive traffic, so that it ends up being discarded. Pictured on the screen, we have an example of a snort IDs rule configuration. Snort is a free open-source intrusion detection system solution. In this case, it's running in Linux, although you can run Snort on Windows as well, and we're looking at the /etc/snort/rules/local.rules file. Well, we can define our own rules for what we think might be suspicious and what we want to do about it. Here it's going to generate an alert on the Snort device. If we have ICMP traffic from anywhere on our home network, then we're going to display or alert a message that says testing ICMP. Now you don't have to build Snort rules manually all the time. There are thousands of rule files that are potentially available in the Snort community that are continuously being updated with the latest suspicious threats. And you can use them with your Snort IDs. So if we take a look at a diagram related to intrusion detection and prevention, let's say that we've got a target here, target computer shown in the bottom left of our diagram. The attacker is shown over on the internet in the upper right of our diagram. Now normally most networks will have an exterior or perimeter firewall that links the internet to an interior firewall between which we would have potentially a screen subnet, otherwise called the DMZ, a demilitarized zone. This is where an organization or an individual can publish public services like a public website or a public mail server or whatever the case might be, something that should be available over the internet, but behind the interior firewall. Is where we would have private services, maybe authentication servers and that type of thing. Now we might have a network switch in which we've plugged in a network intrusion detection system. That means the switch port, of course, would be configured to copy all switch port traffic so that our network intrusion detection system would be able to see all of the traffic passing through the switch, and our intrusion detection system would then be configured with alert notifications. If anything suspicious is detected, bear in mind that what's suspicious for one organization on one network might be totally different than what would be considered suspicious or normal for a different organization. So these ID rules need configuration and tweaking. Snort is a free and open-source intrusion detection system, or an IDS. We've mentioned IDSs and the important role they play in securing a web application by monitoring activity and traffic, either at the network or the host level, looking for suspicious activity. So the idea then is that we can download and install the Snort IDs on a variety of platforms. So if I click Downloads, here we have a number of binaries available for different platforms. We've got an exe for the Windows platform. We've also got a number of RPMS, Red Hat Package Manager type of installers for different platforms. We've even got the source code available if you want to compile it to work on a platform of your choosing. But if I go back here in my browser, I can also download rules. Now Snort rules are statements of which you can organize many of them in a single rule file for things you want to look for. For example, over under rules, specifically under the community rules, we've got a Snort version 3.0 community rules file. I'm going to go ahead and download that just for fun so we can take a look at the contents. So I'm going to go ahead and right-click and unzip that file. That will result in a TIE archive or a tar file, which again I will go ahead and extract, and then it reveals a folder with a number of files. What we're interested in primarily is the Snort 3 community rules file. Let's go ahead and open that and examine it. So we have a number of comments. Those comment lines begin with a hashtag symbol. Now, besides installing the Snort IDs tool and have it running on the platform of your choice, you can also load these rule files on that installation, so the rule files will be read by the Snort engine. These rule files are updated periodically as there are new types of threats that emerge. For example, as I go further down, we've got an alert here that displays an alert message on the Snort tool about TCP traffic from the external network from any port going to a variable called $home_net going to HTTP ports where it's some kind of a web vulnerability scan attempt. As we go down through here, we can read the syntax for all the different types of attacks that get checked for by IDs, including cross-site scripting attacks. Needless to say, this is an absolute goldmine of a tool that we absolutely must have running on the network, whether on-prem, in the cloud, whether it's a physical appliance, a virtual machine, software you install on a host, whatever the case is, there needs to be an intrusion detection system on the network where web servers reside. Now I've switched over to Kali Linux, although it could be pretty much any distribution of Linux, but let's say I want to install Snort here. Here I could run as you do to run elevated commands app install, and then I'll tell her I want to install Snort. It wants the password for user Kali, which is also Kali. It asks, do you want to continue? I'll type in the letter Y and I'll press enter. So it then gives me a note about configuring Snort. I'll just press enter. It wants the address range for the local network. So let's say it's 192.168.74.0/24. If you don't know this information, talk to network admins who would know that. I'll just go ahead and tab to OK, and basically it's installing everything required to get Snort up and running. So here in Linux I can also run snort -- version to ensure that Snort is installed, and of course importantly to see the version of the Snort engine. Here it's returning 2.9.15.1 with a specific build number. Ultimately, I can run Snort with snort -c for config file, which we know is in /etc/snort. It's called snort.conf. We can also specify -l. These are lowercase letters for parameters for logging. Maybe I want this to go under var/log/snort. Now notice when I try to do that I get an error. It gives me a permission denied when it tries to open the rules file under etc. snort wall. Of course that's going to be because I didn't run this with elevated privileges, so up arrow key to that command again, but at the beginning we're going to prefix it with good old as you do to run this with elevated privileges. Now we're ready to rock and roll. So at this point, any alerts in our rule files would be displayed on this screen and ultimately logged to the location that we specified. So that means somebody has to be looking at this, or this has to be configured as a source for a SIAM centralized logging and monitoring system. In this demo, we're going to take a look at the configuration of the Snort IDs, the Snort intrusion detection system, and we're going to go ahead and configure a rule and verify that that rule gets reported. Specifically, we're going to create an ICMP Internet Control Message Protocol rule, things like ping. And the traceroute command will use ICM as their underlying transport mechanism, and they will trigger an alert rule to display on the Snort console and ultimately be logged. But first what we're going to do is poke around a little bit in some of the Snort rule files here in Linux. And if you're a Linux command line person, grep is your friend. Grep is a line filter, and you can quickly sift through all of the Snort rule files looking for something specific to see if there's a rule related to cross-site scripting attacks or directory traversal attacks and so on. If I were to run as you do cat/etc/snort/snort.conf the config file and pipe that to more to stop after the first green fall, we'll be able to go through and take a peek at this configuration file for Snort. Really what's important here is we have definitions for a number of variables like homenet for your home network versus telnet servers versus SMTP servers and so on. And these can be used when you are writing Snort rules. Now also if I were to run sudo let's say ls/etc/snort/rules, we have a number of rule files. They all end with .rules. So community rule files, some that are specific to DNS, suspicious activity or denial of service rules or FTP rules, and so on. We've got a lot of rules here that we could work with, and they're automatically set to be used. For example, why don't we take a look at what exploit.rules? That sounds interesting. So if we were to run sudo cat/etc/snort/rules/exploit.rules, and we'll pipe that to more, and as we go down through this file, we have a lot of alert rules here that are going to display a message of some kinds, such as an exploit for Netscape or whatever the case might be. But what we can also do is run as you do, let's say cat/etc/snort/rules/*. And what I might do is grep that or pipe it to grep the line filter looking for XSS cross-site scripting. So will Snort try to detect any kind of cross-site scripting attacks against our web app? Oh yes, we've got a lot of hits here where it's going to be looking even for that. Now that's not to say that Snort is a web application firewall. It should be used in addition to a web application firewall, but it does look for a lot of these items. So the interesting thing here is you can check your rules for anything that you think might be of interest. If I looked for CSRF, cross-site request forgeries, nothing. If I were to look for other things like directory traversal, and put that in quotes, yes, if that does show up, we have a lot of hits. So the point is, there's a lot of stuff that this is doing out of the box for you when it's running. Now we've not yet started Snort, but we'll get there in a minute. But the first thing I want to do is actually open up. So I'm going to run as you do. I'm going to open up with the nano text editor /etc/snort/rules, and I want to open up the local.rules file. Here I've already added a custom rule, so let's go to alert of any ICMP traffic from any network, any port going to our home network, any port number, and the message will be testing ICMP, and I've got an ID here of 1,000,001 revision 1. Now each of these specific components here is separated with a semicolon. The full colon separates an item like rev for revision against its value, in this case 1. And the class type here is an ICMP event, so that if I have any ICMP traffic, maybe traffic generated as a result of the ping command against this host or trace route, then this will be triggered and we'll test that out. Maybe we'll ping this Linux host to see that our testing ICMP rule actually shows up. At any rate, I'm going to press Ctrl X to get out of that file, so we've got that added so you can add your own custom rules based on whatever you want to do. However, it means having a bit of an understanding of the syntax within the Snort rule file. Whenever you make a change to a rule file or the configuration of Snort in any way, you want to make sure so that it's valid. So we could do that with su do snort -T for test and -lowercase ith0 because Snort has to listen on a network interface and -lowercase c for the config file which by default is /etc/snort/snort.conf. So I'm going to go ahead and press enter on that, and what we're looking for at the bottom is that Snort successfully validated the configuration. Excellent. We're ready to go. What that means is we're ready to start Snort. We can do that with su do snort A for alert to the console-q, which means quiet mode, and finally -c for our config file of /etc/snort/snort.conf. So it'll automatically use our rule files, and right now it's in listening mode, so we're going to test this. I'm going to ping this Linux host from a Windows host to see if our testing ICMP rule gets triggered. So here from a Windows box, we're just going to ping 192.168.4.108, which I know is the IP address of our Linux host. And sure enough, we're getting a reply back. Well, that tells me that it's not been firewalled to prevent that type of ICMP traffic, but let's go check our Linux console to see what's up. Sure enough, we have a lot of testing ICMP messages for each of the echo requests that were sent from our Windows ping command. Now notice we also have a couple of other rules that look like they have kicked in, such as universal plug and play or UPnP, some kind of scan or discovery attempt, and that might be normal for devices on your network if they're enabled for universal plug and play. So it's reading all of the rules from the files and displaying the alerts. In this demonstration, we're going to be taking a look at a Wireshark packet capture in order to identify suspicious network traffic. We're going to be doing this manually. Of course, it could be automated with an intrusion detection system. So what I've done here is I've gone to the itf.org site and searched up the request for comments or the RFC for DNS text records. Now we know that DNS, the domain name system is a centralized lookup server where most commonly clients will query for a name seeking the IP address because that's what they need to make the connection over the network. But this RFC is really focused on a text record. A text record in DNS is really just a way to store some kind of arbitrary information in DNS, like a printer name. It could be anything. The format is that you have the attribute name followed by an equal sign in the attribute value. Now, what's interesting from a security perspective is that this is one way that infected computers know where the command and control server is. There are many different methods, but one method is that the attacker will infect a computer, usually by tricking a user to click on something or open a file, and they'll infect it with malware that is designed to go into DNS looking for a specific text record to find the URL of a command and control server to receive further instructions from. Now, this can be detected if you have enough infected computers that are going out to the same strange DNS. Now, this can be detected if you've got intrusion detection enabled correctly. If you've got computers performing frequent DNS-TXT queries, that's not normal because it's very rarely used. Not only that, if machines afterwards that issued those DNS-TXT queries are going out to the same strange URL, that's definitely an indication of infected computers on the inside. Okay, so here in Wireshark I've got a packet capture where I know there is this type of activity that we've just described going on. I'm going to filter the traffic for DNS, and if I select one of these packets, we've got a DNS standard query going to 8.8.8.8. So first of all, is that a valid DNS server? From my Windows command line I will run the nslookup command name server lookup. I'm going to set the record type I want to query to PTR. A pointer record is a reverse lookup record. In other words, I already know the IP address. I'd like to retrieve a name to go along with it, and I get a non-authoritative answer, which means from a different DNS server that's referring this as being a DNS server for Google. Okay, that part's cool. That makes sense. So I'm just going to exit out of there. Back here in Wireshark, why don't we examine the packet header for that given packet a bit further? So we've got the standard Ethernet or hardware header with MAC address information for source and destination. We've got the IP header for IPv4 with a number of different fields, but of course notably the source and destination IPv for addresses. So we've got a client with a given source address doing a DNS query to Google, and DNS client queries occur over UDP, the User Datagram Protocol, where the destination port on the DNS server is UDP port 53. Okay, let's take a look at the query itself. So it's a standard query. Well, within the domain name query header, if we go into queries, wait a minute, the DNS record type being queried here is a text record for what looks to be a strange unrecognizable URL. Why would the source computer shown up here, by IP address be doing this? Is that normal or is it not? Maybe it's normal for your environment. Remember, when you do security incident reporting and tweak your intrusion detection sensors, it is unique to each organization, to each network, to each host, to each app. You have to be very careful how it's configured. Now let's assume that there is nothing that we run in our environment. We know this that does DNS-TXT queries. We certainly don't recognize that URL. So does that sound suspicious? Yeah, it does. The great news is that I can go to Aristotle.com. This is a free online service where I can do things like provide what I think are infected files or packet captures that have suspicious activity, even suspicious URLs, and it will tell me if in the general worldwide community this is known to be malicious. So I'm going to go to Aristotle.com where I want to upload a file, and what I've done is specified the packet capture file that we just looked at, and it automatically flips me over to this results page where it looks like from a snort detection utility perspective it's detected 2 alerts, and we can click on it to see what's going on. What is the thing is an alert here? Scroll down immediately commands over DNS text queries and responses. Now this is known not to be normal for a client DNS query activity, and as we go further and further down we have a list of the DNS requests from that packet capture. So it takes that packet capture and analyzes it and presents it in this nice easy to digest format. So we see miscellaneous activity. We also see the attempted user privilege gain, so it looks like a specific type of firewall client exploit. So it's safe to say then that we've got some serious problems occurring here as a result of this capture. And if we click on community, we might even get some details related to what other analysis results have determined to be similar. And if I go back under details on the left, let's say, and if we scroll all the way down, let's say under Suricata alerts, then if I go into a network Trojan was detected here, it's giving me some more details. It's pointing me in the same direction that we originally thought via the packet capture, that we've got some kind of a Trojan piece of malware on the inside that's going out to DNS, Google DNS servers, retrieving information via text record queries, which is usually going to be used so that the infected client knows who or where the command and control server is. So there is value then in simple packet captures. You might schedule them to occur randomly, and you might also make sure they run for a long period of time. Save the packet capture files and immediately. The quickest thing to do is just upload it to an online service like this as opposed to trying to pore through it manually, because you never know what kind of indicators of compromise might result from that activity. So in this course, we examined how to ensure that monitoring is deployed correctly in order to ensure that the timely detection of past security breaches and security incidents in the midst of occurring are caught. We did this by exploring the importance of logging and monitoring. We analyzed CM and SOAR and distinguished the difference between them. We used syslogging in Linux for log forwarding, and we enabled cloud web app performance metrics. We then discussed the difference between intrusion detection and prevention, followed by installing and testing the snort IDs, and then we used Wireshark to examine packet captures.